Greetings from Savannah, Georgia. I am missing being up in Rochester where we can always talk about the weather, and I'm going to get my last opportunity to put you to sleep without benefit of a dark room and a wonderful meal. But I'm going to try anyway. Today I'm going to be looking at crystal, which is my approach. My whole approach as a dilettante crystallographer is to buy unusual crystals and look at them intensely over and over and begin to discover things about them. And today I'm going to be looking at pyrite, which is my first love, and I'm going to be dealing with striations, which was the first thing that sparked my interest in pyrite. I know that sounds kind of strange, but let me tell you a little bit about what striations are. When you get a layer that develops on a crystal face and it starts growing outward, if it doesn't make it all the way to the edge of the crystal, it stops growing, and usually it leaves a very sharp, straight edge, which is the edge of that growth layer. And at times, it actually forms at a vicinal angle and making a long vicinal face. And that's what we're looking at today. I'm going to take the camera now. I want to introduce my wife a little bit. Most people have not met her before. She didn't want to be a mineral widow, and so she went ahead with her life while I studied minerals. Now, to look at some crystals. This crystal right here is what most people associate with pyrite. That's a cube. And as you can see, looking at it, it has a bunch of layers that have grown on it that are layers that have grown on the cube face and spread outward. It's left some rough edges. It's not much of a vicinal face there. But you can see that's growth layers on a cube face. Next we have the Pyritohedral. This one is from Peru. And you can see it has the 5 edge faces. They come in pairs, like a gable on a cube face, and most of the people that have talked about growth layers on pyrite have talked about the pyritohedral faces being a place where layers start on the cube face, which is where the light would be shining, and it spread out to the right and to the left, but didn't complete the spread, and it left edges, and now they've aligned to make a face. But that's not really the case in a lot of situations. My next crystal is one that where we have the pyritohedral face, and it's really disturbed a lot because it has growth layers that have developed at the bottom of the pyritohedral face and grown up toward the cube face, and so there are definitely layers that have developed on the pyritohedral face and not just a result of being edges of cube layers. And if I get the light right, it's kind of hard to do this in terms of reflection, but you can see it's striated, and those striations, along with the striations of this first piece, are called positive striations because they go across the pyritohedral face. But there's also something called negative striations, and if you can see on this specimen from Elba, Italy, they go up and down the face instead of across the face. And that's what we're going to look at today, and particularly on this piece, although I found it on a number of other different crystals. This crystal is really special because when we rotate it around, we have this particular face, and what you see right there is the shiny pyritohedral face, and then we have some little edges in here that are the negative striations, but they're pretty well developed as negative striations, so I'm going to measure them. Now I'm going to ask my wife to hold the camera while I move down to my scientific lab, which is underneath my desk. This is my laser goniometer. Basically what it is a laser pointer with the benefit of twist ties from a bread cover to hold the button down to keep it shining all the time, and it's at right angles to a screen, and this screen is actually done on a trigonometric scale so that I can read angles directly off of it and not have to do trig calculations. And it's set for when I have the crystal at 70 centimeters from my scale. So now I'm going to take my crystal where I have those faces and put it down in the beam, and behold, we have two reflections. One, the brightest one to the right, is the pyritohedral face, and the one that's on the zero is the mystery face. And if you could read the scale, it's right at 12.5 degrees. I'll move it over this way, rotate it this way, and you can see the same thing. It's actually, I have it crystal in a little bit, so it's right at 12.5 degrees, somewhere in that area, and that's close enough for what we need to do. Kind of hard getting back up. Now I move on to my computer where I have a shape software program up, and I've drawn this crystal, and basically what we have is the pyritohedral face, which is the 210, and I've put a trisoctahedral face over here, the 211, and this is a mystery face, the 421, and when I figure the angle up here in the upper corner, we come up with 12.6 degrees. And so that nice sharp reflection, that we have on this face is the 421 crystallographic face. It's very interesting. I've searched the literature and nobody has really looked at that. Nobody has tried to do that. Although since about 1900, they've known about negative striations on pyrite crystals. I just thought it'd be an interesting thing to do. What it points out to me is that the layers that stack on the pyritohedral face, they make a very slight angle where the ends of them stack, and it doesn't want to make a very sharp angle, which means that it's probably a slow spreading face. There's been some indication by some research that the steeper the angle is of the striation, the faster the face was growing. That was on KDP crystals. I don't know if it would apply to pyrite. Kerlite crystals tend to do the same kind of thing as they grow. They tend to have very slight angles on the edges of their growth layers. I think this is an interesting thing. It's worth further research. I cannot explain why on some pyrite crystals, when you get the pyritohedral face, you have layers that maybe most of them develop down toward the bottom of the face where the little point is, while some will spread upward slowly but spread out wide, and others will spread fast up this way and then spread out slowly. That's the result that I have, and it leaves us with a question. There's one further thing I want to note, and that is, let me get the camera again, that a lot of cube faces are heavily striated. They don't show really good layer spread and development. They just show lines across the face. And usually when I put them in front of the goniometer, I get an interesting thing, and I'll do that now. There's a cube face, and where the cube should be is right there. It has some intensity, but there's a lot of streaks because of all the striations. And if you rotate it around and get out toward the edge, well, I have to rotate around further. Suddenly, this bright spot appears, and that's the pyritohedral face, the 210 face, and it's very sharp, which causes me to speculate that a lot of cube faces are actually edges of pyritohedral faces instead of being layers in themselves. I don't know anybody who has come up with that and looked at it, but I think it bears looking at. It might help explain why so many cube faces have all kinds of striations and don't show really strong layers like in my earlier sample, which did that. Thank you for listening. I'll be prepared to answer any questions.